This is 2024, the deferred paper. It's paper 2. We're in section B, the long questions. And this is question 8, which is a question on trigonometry. So we're given this triangle here in part A, and we're told that some of the lengths, 59, 47, and that angle in there is 28. And the first part is very straightforward. Find the area of this field. So this is a triangular field. Find the area. And there's a formula in the tables for area, and it's just a half AB sine C, or if you want to say it in words, a half of any two sides by the sine of the angle in between the two sides. So that's the way of thinking of it. So it's a half the two sides, 59 by 47, by the sine of the angle between the sides, which is 28 here. And you work all that out and you get 651 meters squared. Now the next thing, we're asked to work out the side BC. So that's the side. So I'm just going to call it X to make it easier. And what do I use to find the side there? There's two formulas really for working out triangles like this. And the two formulas are the sine rule and the cosine rule. And there's a way to know which one to use. So here's the tip. If you're ever given an angle and the opposite side, you use the sine rule. Otherwise, use the cosine rule. Let's have a check here. We have an angle, but we don't have the opposite side. We have a side, but we don't have the opposite angle, and the same here. So we do not have a side and opposite angle, so therefore we have to use the cosine rule by a process of elimination. How does the cosine rule work? It's in the tables. It says that any side squared, there's a formula, but I'll just say it in words, it's easier. Any side squared is, again, the other two sides squared, so it's that squared plus that squared, minus 2 times AB, which is 2 times that, by the cos of the angle in between, which in this case is C. So we're going to do that down here. So any side squared is the other two sides squared minus 2 times the other two sides by the cos of the angle between the two sides. And you work all that out on your calculator, and you get, don't forget to get the square root of your answer. People often forget to do that. You get your x squared, but then you get the square root, and that's your distance, 28.16. And watch these little details, they're all worth a mark or two. It's two little places, so make sure it is. Okay. Now, part B is on something different. It's basically, this guy has two balers, a square baler and a round baler. So these machines make bales, they make square bales. So a lot of context in English there to get through, but when you get to the maths of it, it's just basically, the numbers down here is what we're interested in. So the first thing you should watch out for in any question is mixing up units. I mean, you got kilometers per hour here, and you got minutes down here, and you got meters here. It's all over the place in terms of units. So you must straighten that out. In any question where that happens, get that straightened out before you do anything. Get them all to the same unit, because you have to compare like with like, basically. So that's a tip, get all units the same. Now, it probably makes more sense to stay in standard units like meters here. That one's okay as it is. Minutes, okay, we'll stay in minutes for the moment. That's kilometers per hour. So I would take that one first, 8 kilometers per hour. And I'd try and get it into meters and minutes. So do it one step at a time, take your time with it. 8 kilometers, well, a kilometer is 1,000 meters. So that's 8,000 meters per hour. So that's per 60 minutes. Try and convert that to minutes now. 1 hour is 60 minutes. So basically you have to divide by 60 to get what it actually is in meters per minute. And there it is. And then you want, work out how many minutes. So again, be clear what the question is. If you don't know what the question is, it's hard to know what the answer is. So be clear on what you're being asked. You're being asked how many minutes. In other words, we're looking for time t. Now over here, from junior cycle, you should know density triangle, distance, speed and time, how they're related. We're looking for t, as it says there. So time is simply distance over speed. We have our distance in meters, it was given. We have our speed, we worked it out up there. So distance over speed is that. Now, the next question is really on ratios. It's amazing how many students will skip this part, volume. Well, first of all, rectangular is in bold, so hopefully you can't miss that. That's there for a reason. A rectangular solid. What does a rectangular solid look like? Well, there's a rectangle. It's a solid, so it's 3D. So it goes back like this. It's a rectangular solid. And now this solid has a volume. So I'd stop right there before I go any further. That's a trigger word, the word volume. It's very specific in maths. It turns out that there's a formula for the volume of an object like that. And I just know from experience that a lot of people seem to miss that if they forget to write down the formula. And the formula is simply length by width by height. It's a 3D object, length by width by height. So I would put that down. And the answer is given to us. It's 0.415 meters cubed. Now, we're told something else. We're told that the ratios of the three sides are 2:3:5. So, for example, that could be 2, 3, and 5. Now, they're not the lengths, they're the ratios. What we're saying is for every 2 that goes up, that goes back 3, and that goes back 5. So that's the ratio, 2:3:5. How do you handle ratios? There's a few ways to handle ratios. You could write them as fractions. I mean, if I have a ratio, L is to W is 2 is to 3, that's the same thing as saying L over W is 2/3, 2/3. That's the ratio. That is to that is the same as that is to that. So that just take those two first. That's one way of doing it. And I can get L on its own. We'll see why in a minute. L multiplied across by W, and you get this. Take these two together. So that's W over H is 3/5. And you get another formula. And I'm going to get H on its own here. By dividing across by 3. Now back to my formula. The problem really is I have 3 unknowns, and you can solve with 3 unknowns. I need to get just one unknown. So that's what I'm at down here basically. I'm trying to get L and H written in terms of W, so they didn't have only one thing to worry about, which is W. So I filled those both in. L is that, H is that, and I get that by that by that now. Multiply the numbers first. 2/3 by 5/3 is 10/9. And you have W cubed, divide across, multiply across by 9, I should say, divide across by 10, etc. And you get W cubed as this, and get your cube root on the calculator, or W to the power of 1/3, same thing. And you get 0.72, which is, now be careful here because he's mixing up units again. And even though you got it in meters, it was given in meters cubed, he wants the answer correct to the nearest centimeter. So they could trip you up very easily if you're not alert in an exam, the units. So basically 0.72 meters is actually 72 centimeters. And once you have that, then it's easy to go back and get H and L, because L is 2/3 of that, H is 5/3 of that. And you can work out those two here, and that's your 3 answers. On to the next part. Another trigger word, watch out for them in exams at all times. So Heinrich's round baler makes bales in the shape of cylinders. There's a bold. The examiner is putting that in bold for a reason. He wants you to take notice. The word cylinder is a trigger word, and it means it should trigger you to look up the formula in the tables. And you look it up and you get volume for a cylinder is pi r squared h. Also something else of significance here. Another exam technique, convert English to maths. Maths is just another language, just a different way of saying things a lot of the time. So height of each cylinder is equal to its diameter. What's that in maths language? Well, diameter is twice the radius. So what he's saying here in maths language is h is 2r. So if you convert that English to maths, it makes the question look much easier. So now we can use h equals 2r. We can sub it in there obviously for h, and you get this formula. V equals 2 pi r cubed. What's the advantage of that? Well, again, there's 2 unknowns there. But if you sub in h, there's only one unknown, r, to worry about. And we can handle that. We know the answer, of course, is we're given the answer, 2.78. And now we can just divide both sides by 2 pi to get r cubed on its own. And you get this, get r on its own, 0.7621. So that's your answer, that's your radius, 0.7621. Now there's only one thing. Give your answer in meters, correct the nearest centimeter. I've never seen it written like that before, but I guess what the examiner is getting at, answer in meters to the nearest centimeter. So have a look at that. So this answer is already in meters, 0.7621. What would that be in centimeters, just for the moment? 76.21 centimeters. So it's 76.21 centimetres. But he says to near a centimetre, in other words, 76 centimetres. We ignore that bit basically. And again, it's backed into to put that in meters. It's kind of confusing the way he's saying it, but what he's trying to get at, I guess, is just write the 0.76 part, because the part after that doesn't matter in terms of centimeters. So there's your answer, 0.76 meters. Next part, it's a long question, so it goes on for another bit. Heinrich is tiling his patio. The tiles are square. So we're given this diagram down here. This is a square tile, and this is the pattern inside it. If you look at the pattern, there's a circle as part of the pattern, a big circle, and then there's 4 smaller circles within that circle. And he's telling us on the diagram quite clearly that that's that they make a square. If you join the 4 centers, they make a square. We're also told that the radius of each small circle is 1. Now, here's the whole point of the question then, of course, is to get the area of the square tile. In other words, if we could get the length by the width. As a matter of fact, it's a square, so just get the length. Or even better again, we'll see that it's a radius, as it turns out in a minute. Okay, so another good tip for these kind of questions, first of all, as I've always said in paper 2, I've said it in other videos, make the diagram sweat. Make the diagram do all the work so you don't have to, basically, as much as possible anyway. Something else to notice here, again, you'll find from practice with these questions, is use symmetry to your advantage. In other words, if I cut off a corner here, I don't need the other 3, because they're all the same. Everything I need is in this, because if I can work out things in this, it'll be the exact same for the other 3 because of symmetry. The other 3 quarters, basically. So at least that helps not around the question, helps us to focus on what's really important here. If we can just focus on what's going on inside in this square only, we'll be sorted. Okay, the next thing, fill in what you know. The same techniques as I've said before in other questions on paper 2 especially, fill in any hidden radius. That's always a big technique. So I'm going to do that. I'm going to fill in, well, the one was given to us over here, but I'm going to fill in over here where it's more use to me. That's a radius of 1 from there to there. Obviously, that's also the radius of 1 from there to there. And that's 1, that radius from there to there. Fill in hidden radius. I can't overemphasize how important that tip is for paper 2 questions, especially with circles. Okay, so now we have 3 radiuses filled in. That, and that. There's also another radius that's now important. I mean, this is the center, obviously, of the big circle. So we'll call that big R from there to there. So fill in those hidden radius as well. If that's big R from there to there, well, so is that all the way up. And the little bit down here, I'm going to call it X. I don't know what that is from there. That's the one piece I don't really know, that piece from there to there. But I do know that X plus 1 altogether is actually the big radius. So there's an equation. R equals 1 plus 1 plus X. And what else do I know? Well, I can do Pythagoras here, actually. That squared and that squared equals this squared. So in other words, 1 squared plus 1 squared is 1 plus x in a bracket to be squared. So because the diagram has done all the work for us, we don't have a whole lot left to do, basically. We just, as I said, take 1 squared plus 1 squared is 1 plus x to be squared. That's the Pythagoras bit. If you square out the bracket, you get 2 equals 1 plus x by 1 plus x. Work that out with the brackets and you get this quadratic. It has no nice roots, so we have to use the minus b formula. That's the only hard bit of maths really here, or awkward bit of maths. Fill in your minus b formula and you'll end up with an answer for x of minus 1 plus or minus root 2. Now we take the plus 1, because the minus 1, you can't have a minus distance. I mean, if you have minus 1 minus root 2, that's a minus distance for x, which is impossible. So we take the plus 1. That's x, and not forgetting, of course, that the total radius then, the total radius is x, as I said, plus 1 plus 1. So the total radius is x plus 1 plus 1, which is what we got there for x, plus 1 plus 1, and those ones cancel and you get 1 plus root 2. And finally then the tile itself, the area of the tile is just a square, so it's basically, as I did up here at the start, area is L squared. If you take the sides, L by L, L squared. And the length is 2R, R plus R by symmetry. So the length is 2R, the length is 2R, so 2R by 2R, which is 4R squared. And we have R, So we have r here, so it's 4r squared, so it's 4 into that squared. Unfortunately, we're not finished yet. We have to now multiply out this bracket. 1 plus root 2 by 1 plus root 2. 1 by 1 is 1, root 2 by 1, there. Root 2 by root 2. Tidy up, root 2 by root 2 is 2, 2 and 1 is 3. Multiplied by 4, 4 by 3 is 12, 4 by 2 is 8 root 2. And that's the answer, and that's exactly the way he wants it. If you look at the question, he wants it written as something plus something root something. And that's what we got, 12 plus 8 root 2. And that's the end of that question.